For my project, I've created a controllable dynamic sailboat simulator. The program works as follows. First, the program calculates the forces exerted by the keel, rudder, and sail given the boat's current state. Given the forces, it finds the acceleration of the boat and integrates to get the new state. Then, all it has to do is redraw the boat in the new position and check for any keyboard user inputs. The simulation you're looking at right now uses the angle of attack information from a 2002 paper, as well as sailboat dimensions from a J24, which is a popular racing keelboat. The first version of this program had the rudder and sail not controllable, but at constant angles. This was good for examining the stability of the system, which was complicated, far more so than for an airplane. Not all sail and rudder combinations were stable. An interesting task would be to map the stability of different rudder and sail angles. However, this wasn't the direction that I took the program. Instead, I added controls, made the program more graphically pleasing, and added a few features which revealed some interesting phenomena. The most notable of these phenomena is related to the location of the sail's center of pressure relative to the keel. If the center of pressure of the sail is in front of the keel, the boat wants to turn away from the wind, and vice versa. This is known as weather helm, and is analogous to an airplane's static margin. If the keel and sail both act at the center of mass, the boat's rotation is determined only by the rudder. When I implemented having the rudder slowly return to a rest position when the user wasn't giving input, I found something interesting. I initially had the rudder spring back to the center line of the boat. When I did this, even if the sail center of pressure was in the same spot as the keel, the boat tended to round down. That's because the boat has a small amount of side slip, which is necessary for the keel to generate lift. When the rudder was centered, this side slip caused the rudder to generate lift and impart a moment on the boat. The program was corrected so that the rudder would spring back in line with the flow of water, not the center line of the boat, which is what an actual rudder would do. There are many additions to this program which I would like to make, but time did not allow. First, instead of directly controlling the sail angle, I would have the user input be more like a main sheet, which controls how far out the sail is allowed to be, and let the wind take it to the maximum angle. This would make tacking and jibing and luffing easier. I would also like to implement a more precise model for the location of the sail's center of pressure, which will no doubt change the stability of the boat. The addition of a head sail and independent trim of the mainsail and head sail would allow the user to manually control the center of pressure and create a dynamically stable boat. Clearly, this is a very complicated problem, but spending some time really thinking through each of the parts of the problem can yield fascinating results. Thank you.